microphone. I hope you'll bear with me tonight. 24 hours ago, I didn't know I'd be here tonight, so I've pulled something together pretty quickly, and I hope you enjoy what you see. Some of you may have already seen the building. It's started to be published in some of the magazines. It was completed just before Christmas. It's a new head office for the cooperative group, which encompasses 12 different businesses. They do food, which we all know about, but they also do pharmacies, funerals. They have a huge investment portfolio, travel as well, banking, insurance. So it's a real sort of multi-headed beast. So the original brief was actually one of the best we've ever got. It was half a page of A4 paper, just setting out the key things that were important to the client. The cooperative group were fantastic insofar as they told us what their ambition was, they told us what their key drivers was, but they left it to us as their architects to find a solution that captured and conveyed all of those things. This is the completed building. It's now called One Angel Square. It's probably just to the Victoria Station, is just off to my left. It's probably just on the periphery of what's conceived to be at the moment the centre of Manchester, but it's like any sort of organic growth of a city. It's those sort of hinterlands, the edges of the city that, all of a sudden start to have a momentum and attraction in them, and that's how cities evolve and grow. Taking you back, probably this is a shot of Manchester in probably early 60s. This is what was the former head office for the cooperative group. This, when it was completed in October 1962, was actually the tallest building in the UK, even within London as well. So, and for the cooperative board to meet and commission this building, which is now Grade 2 listed, quite frankly, this belongs on Lakeshore Drive in Chicago, not in soot-ridden, bomb-torn Manchester in the sort of late 50s and early 60s. So for the cooperative as a business to commission that building with that vision, given the context of the city, and in those days they weren't regions, they were provinces, was quite visionary, and I think the co-op lost their way a little bit in the probably late 70s, 80s and early 90s, but what they're trying to do now is to sort of re-establish themselves within the sort of the battle in terms of being one of the top 5 retailers in the UK with Tesco's and Sainsbury's and Asda and all that. But when they commission buildings, they're actually quite good at it. They have an historic estate here just next to Victoria Station, and all of the buildings are listed because every one of the buildings is a statement of intent and almost like an architectural sort of a history of the ages, and each one of them defined the age in which it was conceived. So when they put their mind to it, they're pretty good at commissioning buildings. This was the new head office when it was finished. It was the machine, the office is the machine, everybody desks, telephones, teleprinters, it was the sort of as Harold Wilson said, the white heat of technology, ripping through there. Very Miesian, very Chicago-esque, and it was the forefront of the office workplace. Unfortunately, over time, it's actually become a pretty horrible place. There's plants, there's dividers, there's flags on the ceiling. Must have been the World Cup or something. Storage, you've all seen it before. They're also split into 12 buildings, as I said. What they wanted was everybody coming together under one roof as one business. They're a cooperative. It goes back to the very origins of them as a movement 150 years ago about everybody pulling together that sort of collective spirit. They don't have that at the moment because they have people, they have departments that have never met each other, don't know what each other do with their time. So this building was about bringing everybody together again and trying to sort of refocus the spirit of the cooperative movement. In addition to that, it was about creating a workplace that, is relevant to the modern day. Even we're talking about 40 years ago when the head office was built. Even if we step back just over 10 years, I remember, the iMac, that was the vanguard of office design. Everybody wanted one of these things on their desks, you know. And just look at the specification, you know. This thing cost 1,500 quid. You know, it was 16 kilograms in weight, 30 gig of storage. We've got 32 on a phone that weighs 137 grams. This is now an office. You don't need to be at a desk to have an office. We all know this. Flexible working, you know, working smarter, working more efficiently. So this little thing here, the progress in technology over just over 10 years has transformed the way in which we work. We don't need to be tied to a desk anymore. That was a big part of the brief to us. So we came up with all sorts of options for the board. We had, you know, it was quite interesting. We had to split our office into teams. You know, these guys working on this one, these guys working on this one, these guys working on this one. The competition in the office was quite fierce. You know, some sort of arbiter, you know, of you know the sort of the direction we were going in, and all of them shared the sort of the common theme of everybody working together under one roof. And the Atrium was a key part of it. That was seen to be the sort of the social glue that brought everybody together. The thing that was missing within the co-op, you know, today's business of the co-op. Flexibility in working, open plan floor spaces, a completely different way of working. This one in the middle, which we called, each one of them had the name. This was the X Factor. This was the Egg or something. This was the Winter Garden. I can't remember the name. Oh, this one was the Agent Scheme, because they'd be like the commercial agents design one. That was. You can see there's a correlation between the two. What they wanted was a long-term longevity about the building. That, you know, at the moment it's going to be in the initial phase of its life a new head office for the cooperative group. But who knows, in 15, 20 years' time, they may not need 500,000 square feet. They might need 100,000. So they wanted a building that they could compress themselves into, that they may just take this wing and they might sublet this to somebody else and sublet this to somebody else. And, you know, they'd want their entrance and you'd want your entrance and the other guy'd want his entrance. So, you know, the idea of this sort of three-sided building that had actually floor plates that could be subdivided or sublet or sold off separately was quite important to them. But actually, what they didn't like about this was the fact that it looked too distinct. You know, you're in that building, I'm in this building, and the other guy's in this building. So they liked the idea of the subdivisibility further on down the line, but they didn't like the fragmentation of the form. They wanted something. They said they felt it was just saying the wrong thing about everybody working together. So, you know, you can see there's a mutation going on here between these two in terms of the form. And once we strip back the sort of more fluid lines of this one pretty much is that sort of the kernel of the idea. The brief was for floor plates no less than 20,000 square feet, but could be subdivided. But every desk had to be within 7 metres of a window to get the daylight and everything. Because the more daylight we get into the building, the less we need the artificial lights on, and that affects the energy as well. Once you look at that, rather pragmatically, 20,000 square feet, the most efficient form is a building 50 metres by 50 metres with the core in the middle. But, you know, the guys sitting in the middle of the building are, you know, half a mile away from a window. Clearly that doesn't work. So once you say everybody's got to be within 7 metres of a window, but we want 20,000 square feet, you're really looking at a building no wider than about 15, 16 metres. But that's a building about 200 metres long, which A, didn't fit on the site, and B, really didn't go anywhere near creating that sort of connectivity and sort of fluid associations of people that they wanted. So you can see, you know, one thing led to another, and we started to think, well, actually, if we take that 200-metre long building and actually bend it twice and actually create this sort of continuous floor plate, they get the 20,000 square feet, they get the 16 metres, they get the three cores to give them the future flexibility, and everybody's happy. And then, obviously, the residual space in the middle is the huge atrium space that acts as that sort of glue that brings everybody together, but it works as a huge environmental device within the building as well. The cooperative group, when they were formed 150 years ago, they used the beehive as a symbol. A lot of the buildings in Manchester that the co-op have beehives and things sculpted into the fabric of the building as engravings or motifs or reliefs or whatever. So we started to look at these early beehives, which were actually wicker baskets. And we didn't want it to be just a motif in the building. We wanted it to actually be a deeper resonance than that. So we actually started to look at the fabric and the texture and the patterning of this and seeing whether we could sort of weave some of that sort of iconography into the fabric of the building. And these are some early sketches about how the facade might work in terms of, connecting the building, actually making the building, making that strong association with the imagery of the hive. But even at that time, we were thinking about the commercial drivers. This is a very fluid form building, but there's no curved glass. We were very conscious that, as soon as you go down curved glass, it's never mind bending in two directions, but bending in a single dimension. So every piece of glass is flat, and where we get to the corners where we have a very acute radius, we simply triangulate the glass to sort of turn that corner. We've, pretty much managed to, I think, retain most of the sort of strength of the concept. The roof has changed a little bit, for the better, I may add. We've now got terraces which allow people to work outside or get brilliant views across to the city. This is the finished building. Another key thing we wanted to do was connect these two buildings together. This is the CIS tower that I mentioned at the start. It's 1962 listed. I also think what we wanted to do is to have a sort of a common DNA between these two buildings. This one is, as you can see, hard, angular, lovely straight lines. This one is the complete antithesis of that. But nevertheless, if you closed your eyes and ran your fingers over these buildings, they speak the same language. And it was that sort of texture and patterning on the buildings that we wanted to use to connect the two buildings together. And as you can see now, we've got the terraces deliberately facing south to maximise the solar gains. Let's face it, we're not in Marbella, we're in Manchester. Every kilowatt of free energy we want to grab. I should point out at this point, the BREEAM score that we've achieved on this is 94.5%. So it's currently the highest scoring office building in the UK. An EPC rating of A and a DEC predicted rating of A. So clearly energy in use was a key driver for the design of the building. So we deliberately kept the building quite low towards the south to allow those sort of the sunlight to get in, the daylight to get in, so we could minimise the amount of artificial light we're using and also maximise the amount of passive heat. The concrete goes a long way to help us along that route as well, as I'll explain later. The plan is very simple. This is a development of the plan. 3 cores, main entrance, atrium space, intelligent turnstiles that tell you which lift to go. So if some of your colleagues have just arrived and you work on level 5, it will take you to, it'll try and group people together so the lifts are full of people going to level 5 or level 7 or level 9, so you don't get 15 people in a lift going to 15 different floors. So each day when you go in, you'll actually be sent to a different lift depending on the pattern of people coming in before you. Typical floor, as you can see, 20,000 in total. This is the workforce. Effectively, this is the traditional shop floor in terms of a very efficient space, column free. That was part of the brief as well. I'll explain that a little bit more detail. About 16.5 metres maximum span across there. But these softer spaces around the back of the cores are where we have the breakout spaces and support spaces and meeting rooms, with this area here being used predominantly for the office traditional workstations. There's 3,500 people in the building, but there's only 2,800 desks. So that every space needs to work very hard. In the Manchester market, typical lettings are for offices between 3,000 and 5,000 square feet. So this is, again, this is a sustainable approach to design in first principles, positioning the cores, getting the floor plates the right size so that in the future, not now because the Co-op have got it as their head office, but in the future, if you want to let this building in Manchester, you need to be able to offer tenants 5,000 square foot units because that's what the market in Manchester wants. Or they could have 10, or they could have 15, but you can get a 5,000 square foot unit with your own lift, your own front door. Okay, sorry, you share it with this guy, but with identity. You're not coming out the lift, going down the corridor, feeling like you're in some sort of serviced office of whatever. So that was a key part of the scheme as well. And then, as you can see, the roof plan with the step terraces stepping down to the south with brilliant views over the city. That's the view from the top, looking through the window, connecting the building with the city. Wherever you sit in the building, whether you sit here, 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 once you're in these sort of central areas, the height of the balustrade is designed so that a 5'2" person sitting down can see over the balustrade, across the atrium, through this space. And if you look this way, you see the Pennines. If you look this way, you see the Peak District. And if you look this way, you see the city. So that was a key driver in the design of the internal fabric of the building, to be able to make those visual connections from your desk through the building to the city, or by turning the other way, the hills. The environmental strategy was, again, very simple. Getting the basic passive things right first and foremost. So you can see the southern end of the building pushed down, maximising the views in. There's 350,000 square foot of exposed concrete on the soffits, which we're using to create that thermal mass, to reduce the point in time where we have to go to a switch, flick the switch and use energy to cool the building. We have a double skin facade that wraps around the entirety of the building. That acts as a sort of a thermal duvet around the building, keeping it warm in the winter, and in the summer we open the vents at the top to allow that sort of free cooling, and also solar shading. We have concrete earth ducts which bring the air in. It's a naturally ventilated building, but there are no opening windows. So there's 50,000 litres of fresh air per second coming in and going out of the building. So it's 100% natural ventilation, but just not through windows. The client had a preconception that this building needed to have opening windows. It took us about 3 or 4 months working with Bureau Happold, the engineers, to demonstrate that in terms of ongoing energy usage, it was a more efficient building if we actually controlled the ventilation strategy. Also, for city centre sites, opening windows don't work terribly well because you've got acoustic problems, you've got air quality problems as well. So the fresh air comes in. The earth ducts, which I'll show you some pictures of, are huge things that you can drive cars through. There's 3 of them, one going to each core. They're probably at 3-4 metres below the surface, and at that depth, as we all know, the ground is at a constant temperature, between 12-14 degrees C. So we reckon we get about 4 or 5 degrees of free cooling out of those. Doesn't sound a lot, but 4 or 5 degrees of free cooling on a building this size is a lot of energy that you don't need to spend. So the way that the air works, it comes up underground, it goes up through each one of the floors, each one of the cores through ductwork into the floor. We have a 400mm raised floor. The air is fed up at very low velocity, displacement ventilation, dead simple. Rises with computers and people, hits the concrete, cools down, falls, rises. Eventually the stale air passes over the balustrade and through the stack effect escapes at roof level. If for whatever reason the stack effect isn't terribly strong, there are some fans up here that are primarily there for fire, but they can be switched on to help the stale air escape from the building. Another beautiful story about the building is that the fuel we use for the CHP in the basement is powered by rapeseed oil. Nothing new in that, but the rapeseed oil is grown on the Co-op's own farms, so that you have a client that's able to grow the fuel, ship it to the building, burn the fuel, and the CHP is used to heat. It's used for heat, electricity, and cooling through the use of absorption chillers. So we can cool the building using the CHP as well. Any excess energy can be pushed out into the grid as well. These are the earth tubes. There's 3 of them. Without the guy, the scale is difficult to tell, so we asked the guy to stand there. But these are the earth tubes. This is one of 3 that pass underneath the building. And then that's the atrium that, again, the stale air passes out, works its way up to the top and is expelled just above the top of the uppermost core here at level 15. You can see the coffers and the chill beams and the lighting rafts, which I'll show you more of later. Just a shot inside the double skin facade. Unfortunately, this isn't a place people can go into. I always think it's quite monastic in its sort of cloister-like effect. But again, it's just simple things like we use the brise-soleil, horizontal brise-soleil at every floor level acts as obviously a brise-soleil, but also a walkway to clean the glass. You can see there's quite a change in texture here at the bottom. 800 millimeters is a brise-soleil, the rest is a walkway so that guys can clean the glazing. But this is designed so that, as you can see at the top here, it actually lets daylight and sunlight through, because we don't want the brise-soleil to extend beyond 800 mil, otherwise that starts to take the daylight out of the space. We need the lights on more. The vertical members of the curtain walling system, which is a unitized system, the depth of that box varies depending on where it is on the elevation. So externally we have a consistent facade, these ribs and blades that link the building back to the building across the road. They're consistent on the outside, about 120 mil, but on the inside the back box of the mullion varies depending on whether it's on the south or the west or the east. And that was again, we did some modelling with Bureau Happold to work out. Minimum size is 250, but some of them on the sort of southwest, southeast, and east elevations, where you get that low afternoon sun in 3, 4, 5 o'clock in a July day, it blocks the sun. I can't see the glass here. If I can't see the glass, the solar radiation can't get to the glass and penetrate the thermal line. So that works really well. It's just making things. We need a frame for the window. Let's make it do two things. Lovely tapering concrete columns at the base of the building. The reason they're tapering is that in the car park we need long thin blades so we can get the cars to park between the columns. But by the time we get up to the second floor, we need the columns to be square to take the steel frame. So we worked with Bureau Happold to establish these sort of tapering columns that taper in two directions that change from a blade at the bottom to a square profile at the top. That steel column actually goes all the way through because the loads were too great to have a stub and then transfer it through the concrete. But the quality of the concrete was absolutely wonderful. Here we can see the tapering columns connecting with the blades that go through to the basement. And actually we can see some of the coffers, which I'll show you as well later on. This is a shot showing the earth tubes. We can just see 3 earth tubes. 1, 2, 3. You see the shuttering for those coming into the building. There's a big manifold here that captures all the air, and it's then fed out to the 3 cores. But we can see the precast concrete columns. These things were sort of close to 10 tons each, but they were made by Thorpe Concrete in Staffordshire, and who did all the coffers as well. Really, really good quality. Now this is with Bureau Happold, we developed the project using BIM, which I have to say was a fantastic opportunity for us all to get onto the learning curve. And on such a complex project, there wasn't a single instance of anything arriving on site that didn't fit. We had plenty of instances where it didn't fit before it arrived on site, but that's the whole point of the software, to identify those clashes. But I'm sure we've all worked on very simple projects where if a bit of steelwork arrives and it doesn't fit, the impact that has on program and cost and everything is tremendous. But to have a £120 million project, which geometrically is not straightforward, to have no instances of clashes on site, it was an amazing achievement. Just to talk about the floor construction, we went for, you can see here we had precast coffers. These are steel beams, 3 metre centres. We had the precast coffers which were slotted in. We then had polystyrene void formers, and then we had an in situ concrete slab on top, which sort of works the whole floor works as sort of a hybrid steel concrete construction. The reason we went down that route is we wanted to have at least 2.8 floor to ceiling. I think we achieved close to 2.9 in the end. Clearly we were working on tight floor to floors. For commercial reasons, we're at 4 metres floor to floor. But the big driver was the single span. We just couldn't, to do it in concrete and span 16.5 metres would have meant that the depth of the overall floor construction went up quite significantly. So we opted for a hybrid option, so the steel and concrete is working there's a composite action going on there between the steel and the concrete, and I've got some photographs that show how that works. Just hanging below the concrete we have this chill beam, and cold water runs through the chill beam that contains the lighting and the cooling. So after the concrete reaches a point where it can't hold any more heat, only then does the chilled water run through the beams and help to cool the building. These are some of the coffers being made in Thorpe's Yard. These were 6.5 metres long. There were 2,000 of these on the job. This was a test that we did to look at the quality. Clearly, the guys in the shop, this was the jig that they were using for the rebar to create the geometry before it went into the steel moulds. These are the steel moulds. The reason they went for steel moulds is that there were only, even though there were 2,000 of these things on the job, there were only about 20 different moulds that were used. So because each mould was going to be used a lot of times, steel was used because it wouldn't need to be refurbished if you used a timber or GRP moulds. The amount of times that each one mould would be used would have meant that the mould would have been damaged or had to be reworked. So steelwork was used. We used these magnetic formers for the joint lines in the soffit, and the quality of the concrete, I have to say, was first class. It was just ordinary, simple, nothing fancy about the concrete. It was self-compacting grey concrete. This is the underside of it. The quality was very good indeed, to a standard where we could have left it like that, but I'll explain why we didn't later on. Here we go. So this is actually a rig. We set this up in the concrete manufacturer's yard. We actually did a mock-up of the steelwork, so the guys could learn how to handle it, learn how to swing it in, learn how to install it. Also check on the deflection on the steel beams as well. So we did a lot of work before the stuff arrived on site. So here we can see the polystyrene formers going in that enable the structural concrete topping to be poured on top of it. These are some of the concrete coffers arriving on site. The way it works, there's 3 wings to the building, and the 3 different trades worked in unison. The steel workers were working on one wing, putting the steelwork up. The guys were installing the concrete coffers on the other wing, and then on the 3rd wing, the structural concrete topping was being poured. So they were working in a sort of a spiral effect, going up the building in a I'm not sure whether it was clockwise or anti-clockwise, but one way or the other, we had the 3 trades going on at the same time. And here you can see the steel beams and the concrete coffers being loaded in. Here are some of the void formers being carried up, and you can start to see the sort of effect here of the floor plate. And then that's a finished floor just before the structural concrete is poured on. So we've got coffer, void former, and obviously you see the shear studs there that take the concrete when it's being poured on. The concrete, when it's set, it's only when the concrete is set that the slab has its full structural strength. What that did as well is it actually gave us a really nice sort of flat floor for the other trades to follow on. The reason you can see now that the coffers have been painted white, the reason for that was twofold. One, first and foremost, it was an energy-driven thing. By painting the coffers white, we managed to reduce the lux levels in the lighting from 500 lux down to 300 lux. That's a big reduction. It's over a third reduction in energy use. And in a building where we were striving to get a Deck A certificate, ongoing energy use was a top priority. Secondly, there's 3,500 people in this building that aren't architects. Architects love exposed concrete. I'm looking at Andrew here. Most people don't. We had a client that was quite vociferous about the building being something that would work for the people in the building, and I think the combination of the lux levels, the ongoing energy use, and the general aesthetic of the concrete, as I said, the quality of which was first class, led us down the route of painting the concrete with a Kime mineral paint. And here are the chill beams. They came as prefabricated units. You can see it almost, here's the copper piping through which the water flows. Just above here, you can see there is an acoustic mat that we put on. It's very difficult to see because it's white but there is an acoustic mat that's fixed to the slab just to deaden a little bit of the sound before the raft is offered up. Interestingly, you can see the timber trellis there. The BREEAM outstanding rating put an obligation on the contractor to generate no more than 4 skip loads of waste per month. Now, if I cleared my garage out at the weekend, I reckon I could fill 2. So for a 500,000 square foot building to generate no more than 4 skips a month is a huge task. So when the contractor ordered this component, and it was the same for the windows or the carpet tiles or whatever, as well as saying we want 1 number raft with the specification and everything, they also had to say to the supplier of that component, please don't bring your component to site with the following materials, and because we can't get rid of them. You have to package your components so that they're protected, but also so that you don't bring anything to site that you can't take away with you. So a lot of the manufacturers created these bespoke carcasses. These were made in Norfolk by Trox, but Trox developed this little packaging case that we reckon that these things could go between Manchester and Norfolk about 4 or 5 times before they fell to pieces. They'd go back and they'd be fixed. I think some of the guys, I saw a few with like notches on them, so that you could see how many times it had been to site. It's almost like a bit of a competition going on. Some were looking pretty sorry for themselves towards the end. This is the finished effect. Clearly, these holes are for the service. There's no rafts in here yet, but this is for the service runs to work. But clearly, in terms of the reflectance and the light in the space, you can see how that just lifts the space, and you can go in there on an overcast day, and you don't need the lights on. That's a finished floor plate with the rafts in, painted. These little things are the cantilevered arms that go onto the primary steelwork for the outer skin to be hung from. And then we've got the finished building with the rafts, the lighting. This is actually in the cafe area, but again, these booths are used for workspaces, so you can have your dinner there, or your lunch, or a coffee, or whatever. But you can also use it. They're Wi-Fi. They've got plugs. They've got USB points and everything. So the building's all about having other spaces that you can work within rather than at a desk. The building's also got 40,000 square foot of expansion space built into it, because that's a sustainable approach as well. So we have these sort of double height spaces that could, in the fullness of time, be built over. The building has been future-proofed. We worked with Bure Happold and Loughborough University to look at how we can design the building now so that actually it responds to predicted global warming over the next 50 years. So we looked at temperatures, predicted climate change, where we can expect between a sort of a 4 and 6 degree rise in summer temperatures and 30% rainfall in the winter. So the client asked us today to design this building so that it can cope with those changes. So we have a building here that, despite all those changes, the building can still operate. The facade doesn't need to be modified. The M&E systems don't need to be modified. Yes, certain things might need to be replaced after 10 years or 15 years, but the system per se that's in the building today has been designed to accommodate and work with those changes. So that's a sustainable approach as well, that you actually building in resilience to the building. We're almost there. I think I've got 3 or 4 slides. I thought I'd just show you the finished building. It's always like this in Manchester, nice and sunny. That global change thing, it's already happening. The climate change. It's always blue sky and shining. There's a beautiful colouring. There's an anodised finish to the aluminium, a bronze anodised finish that has a lifetime guarantee. There's some buildings in the city that were built by the city, the City of London, that were built in the 70s using this finish. It's called Analock, and if you ever get the chance to use it, it's brilliant. You never need to clean it, you never need to wash it, you never need to look after it. It doesn't rust, it doesn't break down, it's absolutely bulletproof. And it's the best finish you can ever get. The client paid an extra £125,000 for that over and above powder coating, but they said no. The contractor wanted to use powder coating, but the client to be fair to them, said no, we'll spend an extra 125 grand now, because then we know we don't need to clean it, we don't need to look after it, we don't need to repaint it, it'll never fade. And it was a really, really wise decision to make. Again, beautiful sunshine, terraces. This is outside of the cafe on the 8th floor. So you can have the beautiful views over the city. This is just looking over some of the rooftops. So we've got that sort of. I love the sort of conversation that's going on between these two things. The sort of, the king is dead, long live the king sort of thing. This used to be the head office, and now this is the new kid on the block. But we tried to get that connection and sort of between the two visually. And this wasn't the day the Pope was elected. This is the rapeseed oil coming out. It's actually quite distinctive on the Manchester skyline now. People like the white smoke. It's part of the scenery. There we go. Thank you very much.